Hi, my name is Dr. Rob Ward, and I want to welcome you to another video segment in the redoxdoc.com video conference series. This class is dedicated to understanding seasonal affective disorder, abbreviated SAD, and looking at the redox connections that exist in this condition. As there are in most any health condition, there's always a cellular core level that we can implicate the effects of redox molecules in the pathophysiology of that condition. So let me share with you a little bit about what seasonal affective disorder is, what are the common treatments in the medical world, what's behind this problem, and then talk a little bit about some science that pertains to depression and SAD in particular, and then to think about ways we can provide some redox support. So seasonal affective disorder is fairly prevalent. It's more common in the northern hemisphere. The further you get to the poles, the worse the condition is. So for example, in the United States, the average prevalence is 1.5%. But in Alaska, it's almost 10%. In the Scandinavian countries, it's in the teens in terms of prevalence. So there seems to be an obvious connection to daylight. And so this was first recognized by an American, a scientist by the name of Norman Rosenthal in 1984. And he was noticing that in the areas near where he lived and worked in New York, that in the wintertime when there's a tremendous amount of cloud cover and short days, there were a lot of people who were exhibiting major depressive symptoms. And he thought there might be a connection to the seasonal expression of this. They'd get better in the spring and worse in the fall. So it is a distinct entity of its own and represents a major category in the DMS-4 as you look at the psychology nomenclature of the various psychological diseases. It represents symptoms including a decrease in energy, changes in sleep, major mood depression, and people have suicide ideations, all kinds of problems associated with this. So the causes are believed to be related to dropping serotonin levels, also changes in melatonin, which are associated with sleep. And this has led to many studies that have looked at light therapy for treatment with full spectrum light and the use of serotonin reuptake inhibitors as medications to treat this. Medications like Prozac, Paxil, Lexapro, and such. So some interesting things are this. So think of this as a nerve talking to another nerve. It's called a nerve transmission. And nerve connections, or when we have a thought, we connect the dot, one nerve has to send a message to the next. And if the messages are getting through, we stand a chance of having normal biology, normal thoughts and mood and so forth. The problem comes when the connection doesn't happen. The message doesn't get transmitted across what's called a synapse. The synapse is a gap between one cell and the other. And there are chemicals that are used by the body to transmit the information from one cell to the next cell. In this case, in the gap is serotonin. It could be another neurotransmitter, dopamine or whatever. The chemical is secreted by this cell, taken up by this cell to complete the connection, and then it gets recycled by the origin cell in order to conserve the molecules and maintain a proper level. Well, that reuptake process can get disturbed. There may not be enough serotonin produced by the nerve cell, and that's where the problems develop, okay? So an interesting study that was done in Norway, and Norway's got some interesting geography because there's definitely an inland culture and a coastal culture. The coastal culture eats a lot of fish because that's what they do. They fish along the coast. The inland culture raises a lot of dairy, and so they don't have the seafood as their mainstay. They have beef and other, farm kind of products for their main foods. So there's a kind of a distinction there. And what's interesting is that the people that live along the coast have less seasonal affective disorder than the people who live inland. And it's thought to be related to vitamin D levels that we find more prevalent in seafood and fish. The fish oil is loaded with vitamin D. And so this is not so much the case anymore. This was years ago, but we have fortified milk nowadays where there's extra vitamin D. And so this contrast is not so amazing. But if you look up the symptoms of low vitamin D, depression is the #1 physical effect of deficiency. So, interesting thought. Well, let's talk a little bit about some research quickly. In one article I reviewed, there's a protein called serotonin transporter protein. It's involved in the synapse process, and it is higher in the winter time, which will cause a lower serotonin level. This study was a pretty small study involving about 30 people, but they did brain scans, what are called fMRI studies, and they showed that people that had seasonal affective disorder had 5% higher levels of this protein, which lowers serotonin, than compared to the volunteers who didn't have SAD. Kind of cool. The next study I looked at was the International Journal of Neuroscience. It's a pretty old article talking about L-tryptophan. And in those days, in the 90s, L-tryptophan was kind of an interesting supplement. People were exploring the use of this as a supplement because we know that L-tryptophan is an amino acid precursor to the production of 5-hydroxytryptophan or serotonin. So the question is, what happens if you supplement this in the body? Just kind of give a bunch of L-tryptophan, and it turns out that it is a positive effect. You find L-tryptophan in dairy and chocolate. People notice that they have a better mood when they're eating chocolate. Well, now this is thought to be part of the reason. Helps to raise your serotonin levels. And that may be useful in dealing with the effects of SAD. So let's talk about what else can we do? If we know this is happening at a cellular level, what can we do to affect the chemistry of those synapses and really get deeper than supplements and light and where you happen to live and the food you might eat? Is there something deeper? The answer is there is. In today's day, we now understand that at a cellular level, there are molecular changes that are happening, and we can impact that directly. So today, we can supplement our body with actual redox molecules. Redox molecules are tiny little molecules manufactured in our cells normally when we're in balance. And we produce positive and negative redox molecules in our mitochondria. But in our brain cells, in our muscle cells, when we're out of balance, we're not going to produce the same levels. We're not going to produce the same balance. And this leads to problems in the cellular pathways. So we now know that redox molecules activate the membrane reuptake mechanisms right in the synapse and help to maintain a healthy balance of these neurotransmitters. So when you supplement your body with these molecules, you actually improve the efficiency of these little reuptake mechanisms right at the membrane level in the synapse. I mean, that's way deeper than working with eating chocolate. Number 2, redox molecules aid in the absorption of vitamin D. They actually improve the ability for our body to assimilate this very complicated molecule and then process it accurately within the liver and then convert it in our skin. Redox molecules are critical in that process. And today, it's not a coincidence that there's kind of an epidemic of vitamin D deficiency. And we wonder, well, what's at play here? Why is this happening? Part of the problem has to do with the health of our gut and the balance of the bacteria in the gut and the amount of inflammation that may or may not be there. But also part of this has to do with we're not producing redox molecules as well as we age and as well as we live in industrialized countries. And so we need to supplement these molecules to help with things as simple as absorbing vitamins. And then the last piece here is that redox molecules modulate the balance of our neurotransmitters. In our brain, we have neurotransmitters that are calming and centering and balancing. Some of our neurotransmitters give us energy, motivation, and mojo, to get stuff done. And those have to be in balance, or we're anxious or depressed. And so we need that balance. Modulating that balance revolves around the balance of our redox potential in our cells, in our brain. And so when we supplement balanced resources of these molecules, equal positive and negative, which we can, then we provide an opportunity for our brain to modulate these neurotransmitters. It's not just having a bunch of serotonin, it's having in balance with our other neurotransmitters. And that's where our redox potential is critical in maintaining that balance. So by supplementing, we maintain balance, we improve simple things like absorption in our body, and at this mechanism level, right in the synapse, we can enhance the cell's desire to maintain a proper balance as they try to reuptake and recycle these neurotransmitters to maintain a healthy mental balance. So I hope that's been valuable to you. Seasonal affective disorder is a big deal, especially in the Scandinavian countries, and there's lots of solutions, even at a cellular level. So, yep, we need oftentimes medical therapy to make a difference and to help people function. But that's great. But at the cellular level, you can also provide support for yourself. It's as important as breathing. So I hope that's good. See you at the next class.